Complex fractions might make you feel like you want to run out the door screaming because it's fractions within fractions within fractions. However, I'm going to show you today how you can use the stuff we've already learned to do these problems. This is really just 3 problems in one. The first problem is the top, x over 5 plus 4. The second problem is the bottom, 8 plus 1 over x. The third problem is this symbol. What's that symbol between those two? Division. So the third part is a division problem. So first, let's look at x over 5 plus 4. I really want that 4 to be a fraction, so I'm going to put it over 1. So this is my yellow stuff, my top part of my original complex fraction. If I want to add these together, I need a common denominator. If I multiply by 1 over here, does multiplying by 1 really do anything? No, we still have x over 5. I do need to multiply the top and bottom by x on the right. So we really have here, I think I'm going to do it underneath, x over 5 plus 4x over, wait, what am I doing? I don't know what I'm doing. I'm doing the other problem. Are you all looking at me like, what the heck is she doing? What do I need to multiply this side by? 5, not x. You know, sometimes my brain doesn't work right. It's cool. I just did it again. Times 5 times 5. There we go. Okay, now we know what's going on. So we have x over 5 plus, what is 4 times 5? 20 over 5. We can now add those together and have x plus 20 over 5. So the simplified top of our complex fraction is x plus 20 over 5. Let's now do the same thing with the blue, and hopefully my brain will work properly this whole time. 8, I'm going to change that into a fraction by putting it over 1, plus 1 over x. If we multiply the right side by 1, that's not really going to change it. The left one, what do we need to multiply that one by? X. That's where I was getting that x from the previous problem. Now we have 8x over x plus 1 over x. Now we have a common denominator, so we can add the tops together. 8x plus 1. There is the simplified version of the original bottom part. Now we're going to do the third step, which is divide. How do we do a division problem? We multiply. We keep the first fraction the same, flip the second fraction, and change the sign to multiply. You would need to factor everything you can. The nice thing is these are as simple as they get. So really, your answer here is put the x and the x plus 20 on the top, put the 5 and the 8x plus 1 on the bottom, and that is your simplified answer. You got that complex fraction down to just one numerator and one denominator. Okay, oh, sorry, that zoomed out a little too much. So to look at this again, start with your original numerator and get common denominators, combine it so that you have one fraction. Take your original denominator from the big problem, get common denominators, add them together, get that down to just one fraction. Then it's fraction divided by fraction. Keep the first the same, change the flip the second, change the sign to multiply, and then combine it. Jumping your notes to section 7.5, solving rational equations. Today we are going to look at cross multiplication. The only time in math that you can cross multiply is when you have fraction equals fraction. It's the only time that you can cross multiply. Some of you get kind of cross multiply happy. Once you learned how to cross multiply, you try to do that with everything. If you see fractions, you try to cross multiply because you think, ooh, fractions, we can cross multiply. You can only cross multiply when it's fraction equals fraction. So notice we're actually going to do number 2 first. It says fraction equals fraction. The big hint here is when there's addition and subtraction within your numerators and denominators, get parentheses around the numerators and denominators. That will help you when you have to distribute after cross multiplying. Okay, so cross multiply. So we've got x minus 2 times x minus 1 equals 6 times x minus 2. What do we need to do on the left?
We need to
double distribute, FOIL, whatever we call it. So we got x squared minus 1x minus 2x plus 2. If you need the little thingies to follow that, there you go. On the right side, it's just plain distribution. 6x minus 12. Combine your like terms. What do you think we need to do next? Yep, subtract 6x on both sides and add 12 on both sides. We're basically getting 0 on one side so that we are able to factor. So we are going to get one side equal to 0 and factor. When we factor, we are looking for two numbers that multiply to give us 14 and add up to -9. That would be -2 and -7. So x minus 2, x minus 7. Your next step is to solve. If the factored form says x minus 2, what is your solution? +2 and +7. Okay, up in the directions, do you see how it says check? When you're working with rational functions, rational is another word for fraction. When you're working with fractions, there's a numerator and a denominator. The denominators cannot be 0. So you need to check both of your answers. You don't have to plug it into the entire problem. You really just have to make sure that none of your answers would make a denominator equal 0 because we can't divide by 0. So really we're going to check right there. So if I plug 2 in, what is 2 minus 1? 1, not 0, so it's fine. Now check 7. 7 minus 1, not 0, so it's fine. Both of these answers are fine because they don't create a denominator that equals 0. All right, let's go over and try number 1 because I want you to see that type of problem as well. This time, the only one that you need parentheses on is the first denominator. Take a moment, cross multiply, and see if you can figure out what to do next. So pause the video, give this one a try. When you cross multiply, you should end up with 2x equals x squared minus x. Do you know where to go from here? You can subtract 2x on both sides. So we have 0 equals x squared minus 3x. Anytime you have x squared and x, you want one side to be 0 so that you can factor. But this factoring problem doesn't look the same as some of the others. It's not 3 terms, so you're not going to do the blank times blank thing. Instead, what do x squared and -3x have in common? X. And if you do x squared divided by x, you'd have x left over. -3x divided by x, you'd have -3 left over. This is factoring greatest common factor. It's undoing the distributive property. Remember, you could check yourself right here. X times x is x squared. X times negative 3 is negative 3x. So you could redistribute to check that you have actually factored correctly. Okay, this one's a little bit more challenging to factor or to solve. Anyone know what the solutions are?
3.
One of them is 3.
1.
Close. 0. Okay. This part has the solution x equals 0. This part has the solution x equals 3. Now let's go back to the original problem and check our solutions. We need to check here and here and here. So if I put 0 in, what happens if I put 0 in place of this x? We have a denominator equal to 0. We can't have that because you can't do 1 divided by 0. So 0 is an extraneous solution. Now try 3. If we put a 3 right here, that's fine. 3 squared minus 3, that's not 0, so it's fine. So x equals 3 would be our solution.